Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, we meet again in this video. So this time I'd like to share with all of you, or we look into the lecture 3 of 5, still the topic of random variables, and we move into the new part, we call the new subtopic right now, which is continuous random variables. Okay. So in this subtopic, we are going to find the probability density function and everything that related to continuous random variables. So continuous random variables are theoretical representations of continuous variables such as height, weight, or time. Okay, a continuous meaning is not different from the previous, where we count the things or the object one by one, but by continuous we measured. Okay, we measured the height, the weight, or the time. And continuous random variable x is specified by its probability density function. And this function is defined over the interval from negative to positive infinity. So x is known as a continuous random variable if, so last time in discrete random variables, for discrete, where with summation of all the probabilities of x equal to 1. Okay, do you still remember this? Okay, so now for continuous random variable, we are going to use this, the sign of integral. I do hope that all of you still remember this. And integral for a function fx dx from negative to positive infinity, and it is equal to 1. Okay, so this is for discrete and this is for continuous. So just imagine that this is the graph, and we are going to integrate the function of fx from x equal to a until b, and or not just a to b, but from negative to positive infinity. Okay, and we will integrate from, let's say, x from a to b. Okay, just like in this form here. So then for continuous random variable x, okay class, so look at this. Last time when we talk about discrete, when we call x, let's say from a to b, they are not equal for x a to b. Okay, sorry, this is not it. Okay, last time when we talk about the discrete property of x from a to b, this is not equal to the property of x, let's say from a to b. Okay, because this property contains what we call a including a and including b. But for this one here, it started from a plus 1 after the a. Okay, for example, if this is 1 until 4, 1 until 4, so this includes 1 and 2 and 3 and 4. But for this one, does not include the a or 1 here, it begins with 2, 3, and 4. Okay, for continuous random variable, is whether we call equal to a or less than b, or greater than a, less than or equal to b, or greater than a and less than b. It doesn't matter, as long as x less than, greater than, and less than from a to b, they are considered as equal. Okay, so this is we call for continuous random variable with the property of x from A to B. Okay, so determine the median. Okay, median means that the middle from the probability density function. The median divides the area under the curve into two halves. If the median is m, then okay, from negative infinity to m, fx dx equal to 0.5 okay, into two halves, or from m to positive infinity. So let's look at example 1 here. Show that the function is the probability density function of a random variable x, and then find probability of x less than 2 and find the median of m and sketch the graph of probability density function. And hence, state the mode. Okay, now the first question then, show that the function probability the function of random variable x. Okay, probability density function means that okay, just now mentioned that the function of fx equal to 1 over 4 minus x, for x lies in between 1 until 3. Okay, so let's say if I come up with this one here, negative infinity to positive infinity of the function fx dx equal to 1. Okay, so this is the key to show that this is a probability density function. Okay, so then let's say from 1 until 3. Okay, so from 1 until 3, we are going to integrate the function of fx from 1 until 3, but what about here? The function here is 0. Okay, when the function is 0, integral of 0 equal to 0, so we just take the middle here with the we call the fx with the domain of x from 1 until 3. Okay, because integral from negative infinity to 1 is 0, and from 3 to positive infinity equal to 0. Okay, so we just take the 1 here, okay, with a domain of 1 until 3. So 1 until 3, 1 over 4, 4 minus x dx. Take the 1 over 4 outside, is a constant. So then 1 over 4, 4x minus x squared divided by 2 from 1 until 3. Okay, substitute x with 3 first. So 4 times 3 minus 3 squared equal to 9 over 2 minus, then x, substitute x with 1 here, 4 times 1 minus 1 squared is 1 over 2. Okay, so 1 over 4, 4 times 3 equal to 12. 12, let's say if I simplify this 12 as a 24 over 2. Okay, 12, which is 24 divided by 2. So 24 minus 9, 24 minus 9, which is 15 over 2. Okay, double check. 24 minus 15 plus 9 is 24. Okay, 15 over 2 minus 4 times 1 equal to 4, and minus half. Turn this into 8 over 2. 8 divided by 2 equal to 4. So 8 minus 1 equal to 7 over 2. So minus here, 7 over 2. Okay, so 1 over 4. 15 minus 7 equal to 8 divided by 2. Well, 8 divided by 2 equal to 4. 4 times 1 over 4, or 4 divided by 4 equal to 1. There you go. Okay, so then since fx is greater than 0 for x less from 1 until 3, and integral of the function fx dx from 1 until 3 equal to 1, as I proved in here now, just now. Thus, fx is a probability density function of fx, of x, sorry. Okay, next question. Probability of x less than 2. Okay, so x less than 2 is middle between 1 and 3. Okay, so then in this case we integrate the function of fx from 1 until 2. Okay, from integral from 1 until 2, 1 over 4 minus x dx, and again 1 over 4 integral 4 x minus x squared divided by 2, okay, from 1 until 2, 1 over 4 times 2 equal to an 8 minus 2 squared equal to 4. Substitute x with 2 squared equal to 4 divided by 2 equal to 2 minus 4 times 1 equal to 4 minus 1 squared is 1 over 2. Okay, so 8 minus 2 equal to 6. And this one here, make it as a 8 divided by 2. 8 divided by 2 equal to 4. So 8 minus 1 equal to, okay, 8 minus 2 equal to 6 minus 8 minus 1 equal to 7 over 2. And turn this into a fraction of 12 divided by 2. 12 over 2. So 12 divided by 2 equal to 6. 12 minus 7. 12 minus 7 equal to 5. 1 over 4 times 5 over 2. And it is 5 over 8. Okay. The next question, find the median m. Find the median m. Okay, so for this one here now, we are going to integrate from negative infinity until m of the function fx dx and give you 1 over 2 or 0.5. And again, let's analyze from this number line is 1 until 3. And as you know that we integrate from negative infinity to m. Okay, from negative infinity somewhere around here to 1 until somewhere which is n here. Okay. By the way, there is a function lies in between 1 and 3. Okay. But then there is no function lies in between from negative infinity until 1, and also there's no function from 3 to positive infinity. Okay, so we consider this as a 0 and a 0. So there's only function lies here, called the function here. So it is from 1 until m, 1 over 4 times 4 minus x dx equal to 0.5. And again, 1 over 4 is a constant. Take it outside. 1 over 4. Okay, 4x minus x squared divided by 2 from 1 until m equal to 0.5. Okay, class, even though from our observation here, from 1 until 3, we might think that 2 is the midpoint, right? Okay, 2 is a midpoint between 1 and 3. Doesn't mean that there's a middle for the function, or what we call for the function, because once we integrate from 1 until 3, the graph might be something like this. Okay, so it's what we call it's not the reason. We cannot say that this mx equal to 2 automatically is the middle of the graph, because the area is different here. Look at this one here now. Okay, so not necessarily that this 2 is the midpoint of m median between 1 and 3. Okay, so 1 over 4, substitute x with m, so then 4m minus m squared divided by 2 minus 4 times x, add 1 here, 4 times 1 equal to 4, minus 1 over 2 equal to 0.5. Okay, so 4 times 4 here and times 4 here. Then, okay, for this one we get 4m minus m squared divided by 2 minus, make this one as m 4, 8 over 2. 8 divided by 2 equal to 4. 8 minus 1 equal to 7 over 2 equal to 0.5. Half times 4 equal to 2. Okay, and now we multiply with 2 left and right. So then multiply with 2, you get 8m minus 2m squared. So 2 divided by 2 equal to 1. So there's not 2 then. Sorry. Okay, 2 times 4 equal to 8m. 2 divided by 2 equal to 1. So m squared minus 7. 2 divided by 2 then, okay, equal to 4. Then bring everything here to the other side. Okay, so negative m squared, and here become positive. So then m squared minus 8m, negative 7, then here become positive. So 7 plus 4 equal to 11, it equal to 0. Okay, so then factorize. So m with an m, 11. Is there any values we call numbers, multiplication of two numbers that give you 11? Might be not. Okay, you can use we call the formula of we call this m equal to negative b. Okay, from here, a equal to 1, b equal to negative 8, and c equal to 11. M equal to negative b with negative 8 plus minus square root of b squared negative 8 square minus 4a and c divided by 2a. Okay, so 8 plus minus square root of 64 minus 44 divided by 2. 8 plus minus square root of 64 minus 44, 20 divided by 2. Okay, square root of 20. Square root of 20 equal to square root of 4 times square root of 5. 4 times 5 equal to 20. Square root of 4 equal to 2 square root of 5. Okay, so then 8 plus minus 2 square root of 5 divided by 2. So then there are two answers here, which is the first one, 4 plus square root of 5 or 4. 8 divided by 2 equal to 4, 2 divided by 2 equal to 1, 4 minus square root of 5 Okay, so if I refer to my answers, recall my solution here now. Which I think that where m equal to, okay, so square root of 5 equal to 2.23. Okay, 2.23. So if I come up with 4 minus square root of 5, we still get it positive. Okay, and also 4 plus square root of 5, of course we're gonna still get it positive numbers here. So m equal to 1.764 or m equal to 6.236. Okay, we got two values of m here, but only one is the answer. M 6.236. 6.23 is not a numbers or value, lies in between 1 and 3, am I right? So, of course, this is not the answer. 1.764, yes, it lies in between 1 and 3, 1.7 something right here. Okay, so since that m lies in between 1 until 3, then m equal to 1.764. Okay. So then, what about the graph? Okay, we got an x here and also y. 1, 2, and 3. 3 over 4, 2 over 4, and 1 over 4. Okay, so from here, and the mode is 1. Okay. Example 2. A continuous random variable x has a property density function of this. So find the value of the constant k and sketch the graph of property density function. Find all this again. So again, fx equal to k times x plus 1. Okay, I rewrite the function here and 0 otherwise, where x lies in between 0 until 2, x lies in between 2 until 3, and otherwise then find the value of the constant k. So as we know that integral from negative infinity to positive infinity of the function fx dx equal to 1. Okay, so then from 0 until 2, from 2 to 3, okay, between 0 until 2, there is a function of kx plus 1. There is a function here. And between 2 up to 3, there is also a function of 2k. So the rest of this, which is equal to 0. So 0 and 0 meaningless. So I don't think that we're going to discuss on this part here. So we just take these two domain with this function here, first with from 0 until 2 kx plus 1 dx plus from 2 to 3 2k dx equal to k is a constant, we may take it outside here. Okay, so then x squared over 2 plus with an x from 0 until 2 plus this one here, we just imagine that there is an 2k is a constant, so 2k 1 here, integral of 1 dx equal to an x from 2 to 3 equal to 1. Okay, okay, so now we substitute values 1 by 1 with 2 first. 2 squared equal to 4, 4 divided by 2 equal to 2, plus, okay, substitute x with 2 here, minus, and now we substitute x with 0. 0 squared equal to 0, and also x equal to 0, 0 here. Then 2k, substitute x with 3, minus, substitute x with 2, equal to 1. 2 plus 2 equal to 4, and 0 here. 4 minus 0 is 0. 4 minus 0 equal to 4. 4k. Okay. 4k. 4 minus 0 equal to 4k plus 2k times 3 minus 2 equal to 1. Then 2k equal to 1. 4 plus 2 equal to 6k. Then k equal to 1 over 6. Okay, let's rewrite the function in the full. Fx equal to, so k is 1 over 6. 1 over 6 times x plus 1. For x lies in between 0 until 2. 2 times 1 over 6. Say 1 over 6 here, 2 times 1 equal 2 over 6, which is 1 over 3, for x in between 2 and 3, and 0 otherwise. Okay, so let's sketch the graph of this function. Okay, then x from 0, 1, 2, and 3. Okay, we got 1 over 6, 2 over 6, and 3 over 6. So for this function from 0 until 2, substitute x with 0 here. 0 plus 1 equal to 1, so 1 over 6. From 0, it is 1 over 6. Then x equal to 1. 1 plus 1 equal to 2. 2 times 1 equal to 2. 2 over 6. 1, then come up with 2 over 6. And 2 plus 1 equal to 3. 3 over 6. Okay, 3 over 6. There you go. And then 1 over 3. 1 over 3 is 2 over 6. 2 over 6 or 1 over 3 from 2 to 3. There you go. Okay. And next question. Okay, I rewrite the what you call the proper function of this. Fx equal to 1 over 6 x plus 1 as a reference. Okay, in this page here for x in between 0 until 2, and then 1 over 3 from x to 3, and 0 otherwise. Okay, so the property of x from 1.5 until 2.5. Okay, class. From this domain 0 until 2, 0 until 2, and 2 to 3. As we know that there is a function for domain of 0 until 2, which is 1 over 6 times x plus 1. And there is another function from 2 to 3, which is 1 over 3. So look at this one here now. It is from 1.5 until 2.5. So 1.5 is somewhere around here. 1.5 and 2.5, meaning this domain of x, we call the domain of x for this solution here, across the border of these two functions. So in this case, we are going to separate this from 1.5 until 2. 1.5 until 2 with a function of here 1 over 6 x plus 1 dx plus width from 2 to 2.5, and we refer to the function of 1 over 3 from 2 up to 2.5. Okay, now 1 over 6 the constant, 1 over 6, so integrate this, we get x squared divided by 2 plus with an x from 1.5 until 2 plus 1 over 3 integral of 1 dx equal to an x from 2 up to 2.5. Okay, so 1 over 6, substitute x with 2, 2 squared equal to 4, 4 divided by 2 equal to 2, and x equal to 2, plus with this one here, 1.5 squared, substitute x with 1.5, 1.5 squared divided by 2, it is, oh sorry, it should be minus here. Okay, so this one will give you 1.125 plus with x 1.5 here, plus with 1 over 3 x with 2.5 minus x equal to 2. Okay, so from here you may use your calculator. 2 plus 2 equal to 4, and this one here, okay, you may use your calculator to find the answers here one by one, and this will give you 0.396. Okay, and probability of x greater than 1.8. Okay, according to the question, there is no sign of equal then. Okay, so then here now, okay, you may use 1.8 somewhere around here, okay, up to 2, 2 to 3, 3 to positive infinity. Or the other way around, you may also use this as a 1 minus probability of x less than or equal to 1.8. So the whole, we call integral that give you 1 minus 1.8 from negative infinity to 0, 0 to 1.8. Okay, either one. It's either you use the x from 1.8 to 2, 2 to 3, or you can use 1 minus, we call the integral from negative infinity to 0 is this 0, and 0 up to 1.8 is all comes to you. Okay, 1 minus this one here from 0, okay, from 0 to 1.8, somewhere around here, from 0 up to 1.8, and this we call referring to the function of 1 over 6 times x plus 1. 1 over 6 x plus 1 dx. Okay, 1 minus, okay, 1 over 6 here, and integral of this, it gives you x squared over 2 plus with an x from 0 until 1.8, and this one gives you 1 minus 1 over 6 with 1.62 plus 1.8. Something like that. Okay, you may recall. Substitute, look at this one by one, okay, by yourself. Okay, because 1.8 here, 1.8 squared divided by 2, 1.62, and x, 1.8, minus 0 and 0. 0. Okay, so I give you 0.43. Okay, then next, what is the next question then? Find the median. Okay, the median. Okay, for median, when the function fx 1 over 6 x plus 1 for x in between 0 until 2, 1 over 3 for x in between 2 and 3 and 0 otherwise. Okay, now 0 until 2 and until 3. So the we call the median, it might be somewhere in between 0 up until 2, somewhere around here, or might be between 2 to 3. Okay, it can be anywhere, somewhere in between 0 until 3 here. It can be between 0 and 2 or 2 to 3. Okay, let's try from 0 until n. If I imagine that the n might be somewhere around here between 0 and 2. Okay, for the function of 1 over 6 x plus 1 dx equal to 0.5. Let's try. Okay, so 1 over 6 integrate x plus 1 dx, x squared over 2 plus with an x from 0 until n equal to 0.5. Okay, multiply with 6 here, 6 divided by 6 equal to 1, and multiply with 6 here, 0.5 times 6 equal to 3. Okay, equal to 3 here. And then substitute with m first. So m squared divided by 2 plus with an m and 0, 0, 0. Okay, minus 0 equal to 3. So we got m squared over 2 plus with an n minus 3 equal to 0. To eliminate these two, we multiply everything here with 2 and also multiply here with 2. So 2 times half equal to 1. You get here 2m squared plus 2m minus 6 equal to 0. Okay, so you say that you use the factorization or completing the square or using the formula. Which you prefer then? Okay, it's all up to you then. So use your calculator. You may use your calculator here. Using the correct formula, you get m equal to 1.65 or m equal to negative 3.65. Okay, between these two values, negative 3, too far away. It's not in the range between 0 until 2 or 2 to 3. So this is not one of the answer. Okay, so 1.65 lies in between 0 until 2, somewhere around here. So meaning it is m equal to 1.65. Okay, so the median, we call the median is m 1.65. Okay, so x is a continuous random variable with probability density function of this you see on the screen here now. So the question wants to find the median of m and this one here. So let's find out one by one. Okay, so the first is find the median. M doesn't lie again. We make a test, we test with the, okay, just imagine there is a between range domain between 2 to 3 and 3 to 4. Okay, so the domain from 2 to 3, this is the function, and 3 to 4, well, this is the function here, 2 over 5 times x minus 2, and the rest of it is 0 and 0. Okay, so if we test the first one then, let's say from 2 to 3, 2 over 5 dx. From 2 to 3, the function is 2 over 5. Okay, and this one here, 2 over 5x. Okay, integral of 1 dx equal to x from 2 to 3. So substitute x with 3 first. 3 times 2 equal to 6 over 5 minus, substitute x with 2. 2 times 2 equal to 4 over 5. 6 minus 4 is 2 over 5. And 2 over 5, 0.4, which is less than 0.5. 0.4. Okay, less than 0.5. So, m does not lies in between x equal in between 2 until 3. Okay, so we come up with a conclusion that m lies in between 3 and 4. Okay, so in this case we come up with m until 4. Okay, m until 4 with a function of 2 over 5 x minus 2 dx. Okay, again, just now the domain of 2 until 3 and 4. So between these two domains, there is a function of 2 over 5 and also 2 over 5 times with x minus 2. Okay, when just now we try with 2 over 5 between 2 and 3, and the whole integral from 2 until 3 equal to 0.4. Not even half, not even 0.5, less than 0.5. So means that we call the middle, the m median is somewhere around here. Okay, from 2 to this m and m to this 4. So m is the middle we call the median here now. And let's find out, we call the value, the integral from m to 4 equal to 2 to this m. Okay, so then 2 over 5 x squared over 2 minus 2x from m until 4 equal to 0.5. Okay, so actually that I take this equal to 0.5 here. 2.5, substitute x with 4. 4 squared equal to 16, divide by 2 equal to an 8, minus 2 times 4 equal to an 8, minus, okay, again, substitute x and x with 4 first. 4 squared equal to 16, divide by 2 equal to an 8, minus 2 times 4 equal to an 8, 0, right? Okay, make our life easier. Okay, so now minus and substitute m now. M squared divided by 2 minus 2m equal to 0.5. Okay, so 2 over 5 and this one here, no, 2 over 5 minus times with negative m squared divided by 2, negative with negative become positive, 2m equal to 0.5. Okay, to simplify this until you get, okay, 2m squared minus 8m plus 5 equal to 0. So please, from here, try to get this 2m squared minus 8m plus 5. You will get it, okay? I'm going to give a task to all of you to reach up to here. And then from here, you may use the recall factorization, complete the square, or might be using the formula, or you straightly using your calculator then. And it gives you m equal to 3.225 or m equal to 0.775. Okay, by the way, look at this value m, 0.775. Is that in the range of 2 to 3 or 3 to 4? No, right? So only this, meaning that m equal to 3.225. Okay. Next question. Find the probability of x minus 3 less than 1 over 2. Okay, you still remember this? Modulus of x minus 3 less than 1 over 2. And this one we define as x over 3 less than 1 over 2 and greater than negative 1 over 2. Okay? Okay. So means that here, this is probability that negative 1 over 2, no, x minus 3 and 1 over 2. So simplify this, and this will give you 5 over 2 with an x, and also 7 over 2. Okay, so between 2 and 3 and 4, 5 over 2, okay, 5 over 2. 5 over 2 is 2.5. So this is, okay, 2.5 and 7 over 2, 3.5. So means that is from here 2.5 or 5 over 2 until 3.5, 7 over 2. So it crossed these two borders here. Class, this example is exactly the same as the previous example 2, when we need to integrate, and the function, recall the solution of this cross two borders between these two domains, from here 2.5 up to 3 and 3 to 3.5. So what if I just give the recall task to all of you? Okay, and okay, I add some more here. 2.5 until 3, and this one is with the function of 2 over 5 dx plus 3 up to 3.5 with the function of 2 over 5 x minus 2 dx. Okay, so you try by yourself, and the final answer for this I give you straight to all of you to try, which is 9 over 20. So please try this again, use the previous example as a reference, and until you reach this here, good luck. That's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.